Hi everyone, so today's summer work video, we're going to be talking about factoring perfect square trinomials, but let's just review real quick. In our last video, we looked at factoring and we talked about what it was. And if you remember, I said it's like splitting an expression into a multiplication of simpler expressions. And last time we looked at dots, the difference of two squares. Dots was really nice and easy for us to recognize. Why? Because it was difference, meaning subtraction, of two, so two terms, and they were perfect squares. So example here, x squared minus 181. It's an example of dots. So to factor it, we use the pattern, and it would work out to be x plus 9, x minus 9, okay? Today we're going to be talking about another factor pattern called perfect square trinomials. I like to refer to them as PSTs. PSTs. Well, this is a trinomial now. Difference of squares was a binomial. So a trinomial will be in the form ax squared plus bx plus c. So it'll have three terms. It'll be in descending order by exponents. So for quadratics, we say that's standard form. B will not be 0, because if it was 0, it would only be two terms. And A and C have to be perfect squares. That's the good news. And a couple other things have to be true. B has to be an even number. Okay, so if it's not, then it's not a perfect square trinomial, and the pattern I'm getting ready to show you won't work. All right, so for me to verify if something's a perfect square trinomial, if it's a PST, I ask myself, is the first term a perfect square? So I look at the first term. 16x squared is a perfect square because square root of 16 is 4 and the square root of x squared is x. All right, then I look at the last term. Is the last term a perfect square? And yes, 9 is 3 squared, so it is a perfect square. Now, if this is 4x, if that's its square root, and this is 3, the middle term has to be twice the product of the square roots of the first and last terms. So 4x times 3 is 12. This number would have to be double or twice that product, which is 24. So this is a perfect square trinomial. All right, so if I want to factor a perfect square trinomial, I take the square root of the first term, which we already said was 4x. I take the square root of the last term, which is 3. I always take the sign of the middle term, and that'll be my term, and this would be quantity squared. 4x plus 3 quantity squared. If you forgot the pattern and you factor it just using regular trinomial factoring, it would work out to be 4x plus 3 and 4x plus 3. They'd be exactly the same. So notice the difference between this and dots. Dots, these would be opposites, or they'd be opposite signs. One of the signs would be opposites. All right, so let's check this out. We're going to determine whether each trinomial is a perfect square, and if not, we can't factor it. But if so, we're going to use the special rule. All right, so I look at this one. 4x squared is a perfect square. 9 is a perfect square. All right, so the square root of 4x squared is 2x. The square root of 9 is 3. 3 times 2x is 6x, and 12x is double it. So you know what? It is a PST. Check. So now I can factor it. So I'm going to have a binomial squared. My first term is going to be 2x. My last term is going to be 3. And the sign is going to be positive. All right. I look at this next one. Now, I do always want to see if I can take out a GCF. Okay. So I'm going to take it. I notice that all of these are divisible by 6. So I'm going to pull out a 6. I'll be left with x squared plus 5x plus 6. All right. So now I can already tell that this is not a perfect square trinomial because 6 is not a perfect square. Now that doesn't mean it's not factorable, but we're just not going to use the rule. Okay. So we're going to move on. It's not a perfect square trinomial, not a PST. All right. Let's try this next one. All right, y squared is a perfect square. Check. 36 is a perfect square. Check. All right, the square root of y squared is y. The square root of 36 is 6. 12y is double their product. So it is a perfect square trinomial. I make a binomial squared, and it would be y plus 6. All right, a little harder. 25x squared, that is a perfect square. 1 is a perfect square. All right, so the square root of 25x squared is 5x. The square root of 1 is 1. All right, 1 times 5 is 5. Double that, it is 10. We disregard the sign here when we're doing that part. So it is a perfect square trinomial. And so our result is going to be the square of a binomial, or a binomial squared. So 5x minus 1. 5x minus 1. Couple more. All right. X squared, it is a perfect square. Square root of 4 is 2, so it is a perfect square. Oh no, look at this. Trying to trick you here. 2 times x is 2x, but remember the middle term needs to be double. And that is not double 2x. So it is not a PST. All right, in this case, I even noticed it's not factorable. So, all right, the last one, number 6. All right, I wrote it a little backwards. Could you rewrite it? Yes, you could rewrite it if you wanted to. But you could also factor it in this way. All right, so is 9 a perfect square? Yes, its square root is 3. 16x squared, is it a perfect square? Yes, its square root is 4x. All right, 4x times 3 is 12. 24 is double that product, so it is a perfect square trinomial. So my right result should be the square of a binomial. All right, 3 is my first term, sine of the middle term, so 3 plus 4x quantity squared. All right, so let's just recap. We want to always check, is it 3 terms? Have you taken out a GCF? If it's 3 terms and you've taken out a GCF, before you go on to any other kind of factoring, say, is it a PST? Is it a perfect square trinomial? And then if it is a PST, use the pattern. Makes it a little bit easier. All right, guys, hopefully that helps you. Talk to you soon.